Okay, this is a second part of block 4 in topic 8. We're actually starting on page 247 at number 6. And we have some definitions that we need to complete. First, I'd like you, off in that empty space off to the right, write this example here. With a coefficient, constant, and a coefficient. Two of those are like terms. What makes them like? Do you think? What?
They both have variables and they have a number and a variable.
They both have variables. They both are a coefficient. More specifically, they're the same variable. Do I always have an x?
Yes.
No. Sometimes I have a y. If I was to change this to 2y instead of 2x, would they be alike anymore?
No.
I like to consider the variables like their last name. So if I'm going to a family reunion, everybody's going to have the same last name. Well, these two members could combine in the family reunion because they have the same last name. If they had a Y at the end, they can't combine, they're not the same family. Okay, so let's get to describing these variables for number 6. What do we know about an expression so far, Carly?
An expression is a number sentence without an equal sign.
A number sentence without an equal sign. Very good. Can it have a variable in it?
Yes.
Yes. Can it have numbers in it?
Yes.
Yes. Can it have operations in it? Plus,
Yes.
minus, multiplication? Yes. Okay, it can have all of that. So, I like how she said a number sentence better. Let's write number sentence. Well, let me get my pen so I can actually write today. Number sentence containing terms. Those terms can be numbers, variables, and operators. What are operators? Huh?
Oh, the little the plus.
Plus, minus, multiplication, division. So give me an example of an expression. Well, wait, first, important. It has an equal sign?
No.
No equal sign. Okay. Anyone have an example they can give me for an expression? Doesn't have to be fancy. We looked at a bunch yesterday. Harley?
4 parentheses 2 plus
4 parentheses 2 plus
x.
x. Is that an expression? Did she say an equal sign? No, so that works. Oops, you said 4 and I wrote 2. I'm just going to keep writing 2. I'll put a 4 there. That is an example of an expression. Could 2x plus 8 be an expression? Yes. So write those examples. Okay. Like terms. What is the like terms? I just explained what you wrote down a minute ago, and I said they have the same variable. They say terms that contain the same variable raised to the same powers. So anyone have an example of two things that would be alike? What you got?
8x plus 9x.
8x and 9x. Are those two alike?
Yes.
Yes, so those are like terms. Anyone have, you have a different?
10x plus 2x. Wait, 10y plus
2y plus
10y.
2y and 10y are like terms. What about 4 and 5? Are they alike?
Yes.
Do they even have a last name? No, but they're still alike, right? So those are like terms. And what's important about equations? What?
They have an equal sign.
They have an equal sign. It's actually two expressions related with an equal sign. What's your example?
Y equals 4 parentheses 2 plus x plus
Good. I'm just gonna write it. Something else is up. There is an example of an equation. It has an equal sign, so it makes it an equation. All right, let's take a look at number 7. It was actually a homework problem, but I want to take a look at it. Number 7 wants us to combine like terms. First, on the A, I want to know first who is alike. There's 4 terms. Do you see them? Separated by pluses. I want to know who all is alike. Erica, who's alike?
3x, 5x, and x.
Okay. There's not a number in front of x. What number is that?
1.
It's understood to be 1, so I'm going to put a 1 there so I know. Do y'all agree with Erica that 3x, 5x, and 1x are alike and 10 is the outcast? Okay, why is 10 the outcast? It doesn't have an x. So it wants us to combine terms. So they're all going to the same family reunion. So how many total x family members is going to be combined here? 9. So 3 plus 5 is 8. 8 plus 1 is?
9.
So I have 9 x members. Did 10 get to combine with anybody? No, he's the outcast off to the side. So we have combined our like terms. Okay, let's combine family members on B. Who do you see alike? Yes, sir?
Negative 4y and 2y.
Negative 4y and 2y. Anybody else alike with that? No. Okay. So they're going to the same family reunion. What is a negative 4 and a positive 2 combined to?
Negative 2.
Negative 2y. Okay. Are these two same family member or are they different?
Same.
Okay, I'm going to square them. They're a different family. Can they combine since they're the same? What does that combine to?
6.
A plus 6. Alright, C. Who's combining?
3y.
Okay, 3y and negative 3y. Why does that look like a negative 3y? What? It's not a negative sign, I hear. What is that sign?
It's a subtraction.
Subtraction, but doesn't it look like a negative?
Yes.
Can it act like a negative? Yes, it can. That's why I circled the sign in front of it. Notice I circled this is a positive. That's a negative. What's a positive 3y and a negative 3y?
0.
There ain't nobody going to that family reunion. Do I have to write 0? No. The whole family, that last name got wiped out. Nobody else was carrying on that last name. So let's look at the other family. Are they alike, these two?
Yes.
Like terms?
Yes.
Yeah, okay. I'll square those. I have a positive 10 and a positive 8.
No.
No, a negative 8. What does that combine to? A positive 2. I guess that's all my answer then, huh? The other family got wiped out. Okay, on number 8, I don't want to look at the whole chart. I just want to look at the last row because that's important to us right now. And the last row is talking about distributive property. And distributive property looks like this when I have a number outside of a parenthesis. And I like to do the rainbow method here, where this outside number gets multiplied by everybody inside. So draw that, and let's write multiply, because that guy gets multiplied. Okay, and then right here they want to, y'all do realize I'm at the very last row, right?
Yes.
Okay. Right here they want us to make up a problem that looks like this part here. So give me some numbers for the A spot. 4, parenthesis, give me a number for B. I heard a 5.
6.
I heard a 2. Okay. I am going to just use the distributive property. That's where 4 gets multiplied by 5. What is 4 times 5?
20.
20. Then 4 times the 2 is what?
8.
8. Then that simplifies to 28. And that's how distributive property works. Okay, that's the only one I really wanted to look at on the chart. So we'll move on to number 9. Number 9, these equations should look familiar to us. We saw them yesterday with the 3 different methods. Remember making the 3 different methods of people's work? Okay. These are the equations that we came up with yesterday for everybody's work. Should they all equal the same thing?
Yes.
Because wasn't it the same problem, but everybody had a different way of looking at it?
Yes.
So shouldn't it equal the same thing? Okay? This one is already as simplified as it can go, because is there any more like terms? Any like family members? No. Is there any like family members here?
Yes.
Yes. But I also see a distributive property. You see it in the middle? Okay. that needs to be handled. So I need to simplify this and make sure that it matches the method 1 equation. So I do my little rainbow. What's 2 times x?
2x.
2x, so I'm going to write a plus 2x. Then what's 2 times a 1? 2, so I'm going to write plus 2. And then I'm going to bring down this plus 6. Is that the simplified answer? No, because there's like terms. So let's combine like family members. Who alike do you see? 2x and 2x. What does that combine to? 4x. Anybody else that's alike? 2 and 6. What's that combine to? 8. Did I come up with the same equation as method 1? Yes. So was person 2 okay in their thinking of the problem? Yes, they were. Let's see if method 3, they were okay. Do you see combining like terms or distributive property? Distributive property. So I like the rainbow part. So 4 times x is what? 4x. Then 4 times 2 is plus an 8. Any like family members? No. Does it look like method 1? So was person 3 okay in their thinking? Yes, they were. Okay, let's flip to number 10. We're zooming right through on some easy stuff here. Y'all are catching on quick. We want to put an equal sign or a not equal sign in the blanks. So we need to see if both sides are equal or if both sides is not equal. So I notice there's no like terms on this right side of the first one. Do I have like terms or distributive property on the other side? Distributive property. So I can really do some of these in my head. So what is 2 times x?
2 times x.
2x. Does that match? Yes. Okay. What's 2 times 6? 12. So is that equal or not equal? Not equal. So we'll put a not equal sign, which is an equal sign with a slash through it. Okay, let's test the next one. Ooh, I have 2 distributive properties. I have a 5 times 7, which is 35. A 5 times y, which would be 5y. No more like terms. Over here I have 5 times y, which is 5y. And then 5 times 7, which is 35. Are they equal?
Yes.
Why? They look different.
They're just
flipped. Is 5y is positive right here? Is it positive over here?
Yes.
35 is positive here. Is it positive over there?
Yes.
So they are equal. What about the next one? Equal or not equal?
It's equal.
I see 4a is positive. Is it positive over there? What sign's in front of it? Negative's in front of it, or a minus. So is it equal? No. Positive and negative don't match. That's where it tricks a lot of people. All right, let's see if we can do the next one in our head. Looks like the 8x's match up pretty good. Then I have a 5 times 2, which is, so does that match?
Yes.
I believe it does. I got some ugly fractions, but I'm just multiplying fractions, so I could probably manage that. 2 times 1 is 2. 3 times 2 is
6.
So 2 over 6 is 1/3, so that matches. 2 times 3, 6. 3 times 2, 6 over 6, what is that? 1. Did they have the same symbols?
Yes.
So is it equal? It is equal, good. Got a distributive property and then a +1. So -1/2 times A. What is that? -1/2? Okay, so it's -1/2 A. Then -1/2 times 2. What's half of 2? 1. But what's a negative times a positive? A negative, so this is a -1. Then I have a +1. Does that equal when I combine like terms? This part matches so far, right? A -1 + 1, what does that equal?
0.
It's
Yeah,
0, so do they match?
Yes.
Do I have to write a +0?
You have to write it.
No, so do they match?
Yes.
Yes, they do. Okay, for time purposes, I want to go to 11 and work one of the problems from a homework. And I don't care which one I work, so y'all pick A, B, C, or D for 11 that you want me to work.
B. Please, letter B.
D?
B.
B looks the hardest?
Yeah,
Yeah, it looks so hard. Like,
that's the
it
hardest
looks
one.
so hard.
I wouldn't want my teacher to work the hardest problem.
C.
Okay.
D.
D? Okay,
T as in dog. D.
I'll work D. And first I need to read the directions. It says simplify each expression, show all your steps. Hint, all but one of the expressions is going to be equivalent to 1/2 x minus 1. Okay, so most likely it's gonna equal that. Okay, well I don't like my problem way down here, so I'm gonna rewrite it. -1/2 parenthesis x plus 6 plus 2 plus x. Well, I see a distributive property and I see multiple family members, so it's not simplified. So I would do some distributive property first, which is -1/2 times x. What is that? -1/2 x. Then what's a negative times a positive? A negative. What's half of 6? 3. Now I'm going to bring everybody else down. Do they get to be multiplied by half? No, they're not in the parenthesis. Okay, now I need to look for like family members. Do I have any?
Yes.
Who's alike? -1/2 x. And how many x's is that? 1 whole. So I have 1 whole and I'm going to take away a half. So how much do I have? 1/2 x. So I took care of those two family members. Now I have a -3 and a +2. What does that combine to? A -1 or just a -1? Doesn't matter. So did it happen that can these two combine? No, so I leave it as that. Did the D simplify to that?
Yes.
So that one actually worked out. All right, and that is all for block 4. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.